Greetings class, Mr. S here again. Today's topic, identifying types of chemical reactions. So far, we've learned how to write chemical equations correctly. We've learned how to balance them using coefficients. Today, we're going to learn what I call some real chemistry. We're going to be able to look at the type of chemical reaction that we have before us and then predict what products might be made from that reaction. How are we going to accomplish this? It turns out there are 5 common patterns, or what we call types, of chemical reactions. If you can classify a chemical reaction into one of those 5 common patterns, you will be able to predict the products of that reaction in many cases. How are we going to recognize the type of chemical reaction? What we're going to do is examine the reactants given to us, and these reactants will combine in a predictable way. You recognize the pattern, you recognize the predictable way these reactants are going to come together, and you can then determine the products of that reaction. What we will do now is list those 5 common patterns. We're just going to list their names, and then we will take each one in turn and look at, for that reaction, what do the reactants look like? How do they present themselves? What is the pattern? And then we will go through how using those reactants, how we can then form our products. Here we go. The first type, combustion. Second type, synthesis. The third type, decomposition. Fourth type, single displacement. And the fifth type, double displacement. So now we're going to take each one of those 5 types in turn, as I said earlier. Learn how to recognize the reactant pattern, and then learn how to determine how to form the products. Okay, back to the first type, combustion. Now, when you hear the word combustion, you already have kind of a visual picture of what a combustion reaction might be. Well, a combustion reaction is defined as a reaction between an organic molecule and oxygen, in which heat is released. Now, that organic molecule can be a hydrocarbon or a carbohydrate most often. For a hydrocarbon, we will generally abbreviate that as an HC, or a carbohydrate, because they contain carbon, hydrogen, and oxygen. We'll abbreviate that as CHO. Now let's look at what the reactant side looks like for a combustion reaction. On the reactant side, you would have a hydrocarbon plus oxygen, or you would expect to see a carbohydrate plus oxygen. Once you recognize these reactants, an hydrocarbon plus oxygen or a carbohydrate plus oxygen, this is about the easiest type of reaction to predict the products of, because they always make the exact same products. The products of a combustion reaction are always carbon dioxide, CO2, and water, H2O. No matter what hydrocarbon you have or carbohydrate you have on the reactant side with your oxygen, you will always, always, always make carbon dioxide and water. Let's look at a specific example. If I gave you this set of reactants, CH4, that's the formula for methane gas, that is natural gas, plus oxygen, and I asked you to predict the products. If you notice that CH4 is a hydrocarbon and that oxygen is oxygen, and this is a combustion reaction, you just have to say the products of this reaction will be carbon dioxide, CO2, plus water, H2O. Again, that's true of any combustion reaction. Now let's look at the next type. Synthesis. A synthesis reaction is just what you would think of the word synthesis means. It's where a single product is made from two or more reactants. So on the reactant side, you might expect to see two or more substances, and they will be combining into one. That's the sort of connotation of synthesis. Two or more things coming together to make one. In a synthesis reaction, on the reactant side, we would expect to see, again, two or more elements or compounds. Now, in our class, we're mainly going to be seeing two or more elements. Predicting the products of synthesis reactions where two compounds come together, much more difficult, much harder to predict. We're going to concentrate on those synthesis reactions where two elements would come together to make one compound. And what would you see on the product side? On the product side, you would expect to see one compound. In our case, that one compound will be made by the combination of those two elements. Let's look at an example. If I took magnesium, the metal, and I reacted it with oxygen. Now this is not a combustion reaction because magnesium is not a hydrocarbon. If I took magnesium plus oxygen, and you saw that there were two elements there, you have to think, the only thing these two elements really could do is combine into one thing. That is, magnesium would then bond to oxygen. To predict the product of this reaction, we have to kind of go back to our chemical bonding chapter. And what we would have to say is if magnesium, which is a metal, is going to combine with oxygen, which is a non-metal, what type of compound would a non-metal and a metal form? Well, we learned that metal bonding to non-metal is an ionic compound. If you remember, we did our ionic compound dance where we said ionic, metal to a non-metal, ionic, And if it was ionic, the way you form the compound is you write the next step, the next part of the dance is you write the ions, the ion that magnesium would form, the ion that oxygen would form, and then you use what we call the crisscross method to determine the subscripts in the formula for that product between magnesium ion and oxygen ion. Usually we do that kind of off to the side. If you remember, we could leave this nice space here for our product. Well, let's write the ions. Well, magnesium, you must remember, if it's going to form an ion, it's going to form a 2+ ion. Oxygen, when it forms an ion, forms a 2- ion. And then we would, so we wrote our ions, and now we're going to do our crisscross. What this would say is that 2 magnesiums would bond to 2 oxygens. When there's a multiple in that subscript, we reduce it 1 to 1. All this is a review from our bonding chapter. And so the formula for the product between magnesium and oxygen gas would be MgO, magnesium oxide. Let's look at our third type now, decomposition. In a decomposition reaction, and actually a decomposition, you think of something decomposing or breaking down. Again, that same connotation happens here when we think about decomposition reactions. In a decomposition reactions, it's the opposite of synthesis. 2 or more products form from one reactant. So how would our reactant side look? Well, the reactant side, there's only going to be a single reactant. And that reactant must be a compound. If it's an element, it's not going to break up into anything. And on the product side, we would see two or more products. Now, class, predicting the products of a decomposition reaction are a little bit harder. And so I probably won't ask you to actually predict the products of decomposition, and you'll see why in a second when I write up the example. But I would expect you to be able to recognize that a reaction with one reactant and 2 or more products would be a decomposition reaction. So now let's look at our example. The example I like to use for this I call the pancake reaction, because this is what happens when you make tasty pancakes from scratch. If you take NaHCO3, sodium hydrogen carbonate, and sodium hydrogen carbonate is the active ingredient in baking soda. It will decompose. It will break down under heat. So actually we could write heat above here as a reaction condition, right? It will break down into 3 products. Na2CO3 is sodium carbonate plus carbon dioxide gas, and it also makes water vapor. So you can see that this is a decomposition reaction because we have one reactant, and actually it breaks down into 3 or more products. How does this make your pancakes fluffy and tasty? Well, it's the CO2 gas and actually the water vapor. Those gases, as the sodium hydrogen carbonate breaks down, those gases are released, and the pancakes, they bubble up through the pancake batter and make those pancakes light, fluffy, and tasty. Now stay tuned for part 2 of our video. Part 2, we'll talk about single and double displacement reactions.